slide that you had earlier about like definitions of graph networks, is that hardware dependent? So those conclusions basically for forms of hardware which are specialized towards dense matrix multiplications like GPUs, TPUs, etc. First question.
So the slides of aggregations was mostly about GPU programming style, where you can actually use the scatter and scatter to parallelize across edges using atomic operations, degree bucketing to parallelize using dense representations, and so on. I assume it is the same for TPUs, but I have to say I'm not that familiar yet with that.
I think at least the stuff about gather and scatter and sparse mol should be the same in my experience. And then as there's more interest in like efficient implementations of sparse neural networks, like from a hardware perspective, do you expect this to change the graph neural network community at all? Or at least the conclusions on that side?
That's a good question. One thing I think where like this GPU programming style comes to its limitations is the processing of heterogeneous graphs, where you actually want to parallelize across different node and edge types. And we might see better hardware support that actually can make better use of heterogeneous graphs and parallelize across that. So it is quite an effort to implement a fast heterogeneous GNN variant on GPUs.
Cool.
Thanks, Matthias. Actually, I have one question. So for those efficient application scheme, what is your recommendation for the user for the visual computing people? For example, we are doing these files and meshes. Which application scheme you recommend?
It's a question like which recommendation to use for computer vision?
Yes, for point counts and meshes such special graph structure data.
I would say if you're working on a k nearest neighbor graph, there's nothing better than the degree bucketing approach, because you can just reshape that into the given form. You have to be cautious in the sense that your graph needs to be ordered according to destination nodes in order to do that. But it is quite, if you're just leveraging like scatter max, scatter some aggregations or mean aggregations, then the gather and scatter approach can be competitive to that too. I would say it doesn't really matter that much which approach you use here. Importantly, the sparse matrix multiplication approach does not work in the point cloud processing scenario. Since we're in the point cloud processing scenario, we always have edge features or want to incorporate central node representations. And so it isn't really applicable here.
Thank you. Let's again for
Thank you.